All right, so we're ready to pick up with example number 4. So if you're just watching the example videos, I actually did the first 3 videos with the content video, or the first 3 examples in the content video. So you'll need to go back and watch the content video to get the first 3 examples if you're one of those people who only watches the example videos. All right, so this is problem number 4. It says find the vertical tangent lines of the curve r equals 2 plus 3 sine theta. All right, so I've got this nice little graph here. So let's first use our strategies that we know on how to graph this. So 2 plus 3 sine theta, if I do 3 minus 2, that gives me 1. So I know this thing has a loop, so this is a limacon. Limacon has a loop in it. So it has a loop. I also know it is vertical, so it's a sine, so it's vertical. I mean, it's symmetric on the vertical axis like the y-axis, so it's symmetrical on that. And so it has a loop of 1. It also has a length of 5. If you add 2 and 3 together, it has a length of 5. And it has a width going out 2 in each direction. So it's vertical this way, so I know it has a width going out 2 in each direction. I know it's going to hit the pole as well. I know it's vertical this way, so I know it has a loop that is only 1 unit long. And I know the width is 2 plus 3, or the length of it is 2 plus 3. So the length goes all the way out to 5. So this is what this thing looks like here. All right, so there's your limacon. Try to make it prettier. I don't know if I can. There you go, a little bit better. All right, so there's your limacon with a 1 space or 1 length loop on the inside, and it has an entire length of 5. All right, so that's your limacon. Now, we want to know vertical tangent lines. All right, so vertical tangent lines, well, we know we're going to have one on the left, we're going to have one on the right, and then on your loop, on either side of your loop, you're going to have a vertical tangent line. So this thing's going to have 4 vertical tangent lines. So it's going to have 4 answers. So how do we find vertical tangent lines? Well, vertical tangent lines, you got to know your derivative, right? Because you want a slope that is undefined. Vertical lines have undefined slope. So we need our derivative. So dy dx. So to do polar derivatives, it's dr d theta on top and bottom. And then the top is sine plus r cosine, and on the bottom it's cosine minus r sine. All right, so we're going to fill it in for our function that we have here. So I've got dr d theta. That means to take the derivative of the function r in terms of theta. So the derivative of 2 goes away, and then here the derivative of 3 sine will be 3 cosine. And so I need dr d theta on the top and the bottom. All right, and then the top gets multiplied by sine, and then we add r, we add the function, so I need to put the function 2 plus 3 sine in parentheses, and then multiply that by cosine. And then in the denominator, I'm going to put cosine minus the function r, 2 plus 3 sine, times sine. So this is just a formula for your derivative for polar functions. All right, so now I can simplify this a little bit. Dy dx equals, so this will be 3 cosine sine. Multiplying this out will give me plus 2 cosines, and then plus 3 sine cosine. Then in the bottom, we're going to have 3 cosine squared. That's what this would equal. Then distributing this out would be minus 2 sines, and then minus 3 sine squared. All right. And then the only thing I could do to simplify this any further would be in the numerator to add the 3 cosine sine with this 3 cosine sine and get 6 cosine sines in the top. But I don't have to worry about that right now. All right. So there's my derivative. So I'm wanting to find vertical tangent lines. Vertical tangent lines are undefined. All right. The slope is undefined. So that means my denominator needs to be 0. So let's change our color. So 3, our denominator. So 3 cosine squared minus 2 sine minus 3 sine squared needs to be 0. And then we don't want our numerator to be 0. So we'll come back to that here in a second. All right, if we need to. All right, so now, because we've got our picture to refer to. So let's see. I need to solve this equal to 0. So I've got cosines and sines in here together. So it'd be better if I traded one out. So let's trade out our cosine squared. We know our identity is cosine squared plus sine squared equals 1. So if I want to solve for cosine squared, that's going to be 1 minus sine squared. I'm just moving the sine squared to the other side. So in place of cosine squared, I'm going to put 1 minus sine squared using that basic identity that we know. All right, so now multiplying this out will give me 3 minus 3 sine squareds minus 2 sine theta minus 3 sine squareds. So this is going to give me negative 6 sine squareds minus 2 sine. I just put the higher power first, and then plus 3. So I put the higher power first because I'm thinking I'm wanting to factor this. I can even multiply through by negative 1 to help me out. So that would be 6 sine squared plus 2 sine minus 3 if I multiply through by negative 1. Now, the thought would be to try to factor this. Unfortunately, this is not factorable. All right. So if it's not factorable, I'm going to use quadratic formula. Now, I've not come across very many where you actually have to use quadratic formula, so don't panic or anything. So normally your quadratic formula is x equals negative b because x is our variable that we're factoring, but in this case, the sine is our variable that we're factoring. So sine equals negative b plus and minus square root b squared minus 4a times c all over 2a's. All right. And so then that gives us negative 2 plus and minus the square root of 4 plus 72 over 12, which is negative 2 plus and minus the square root of 76 over 12. So that means sine theta equals negative 2 plus and minus the square root of 76 is 8.718 divided by 12. All right, so then we got our two answers. So sine theta equals two different things. All right. First of all, it equals negative 2 plus 8.718 divided by 12, which is 0.5598. And then the other answer is negative 2 minus 8.718 divided by 12. And that answer is negative 0.8931. So now we need to solve this in our calculator for theta. So that means theta is going to be the inverse sine of 0.5598. Okay? And over here, theta is inverse sine of negative 0.8931. And so we just have to, obviously, this is a calculator-rich problem. So we're doing inverse sine, so that's second sine, and then you're putting in 0.5598, and that's giving me 34. And then over here, you're putting in inverse sine, so second sine, negative 0.8931, and that's giving me negative 63 degrees. All right, so now, notice that's only two answers so far, and we know that there are 4 answers up here. And I also know that the domain up here for theta is 0 to 2 pi. Because in order to map this thing out, we have to go 0 to pi over 2, then we got to go to pi, then you've got to go all the way around here to 3 pi over 2, and then you keep on going here and you end up going to 2 pi. So this takes an entire, so I'm thinking of, again, taking an axis and like rotating it on the pole right here, and as I go around, so as this axis, as this green line rotates up to the top, this curve is going to map out this piece right here from 0 to pi over 2. Then keeping on going around this way to pi, it maps out this part. Then from pi to 3 pi over 2, it maps out from here up to this dot right here. And then from this dot on around here is going from 3 pi over 2 to 2 pi. All right, so it takes an entire 2 pi to map out this entire thing. So notice my answers, 34 and negative 63, they're within 2 pi, except this one's written backwards. think about in the unit circle, if I go negative 63, what is that in the positive direction? All right, so just add 360 to that, and you're going to get 297. Okay, all right, so but that's still only 2 answers. So now I got to think about where's my other 2 answers happening. Where is there another sine value or another angle that has a sine value of 0.5598? Okay, so think about on here, if you're around, here's my unit circle. If I go up 34 degrees, remember my sine is my y coordinate. So that means the other answer is over here that has the same y coordinate, right? Because the sine is your y coordinate. So that means I have to go 34 degrees this way to be a mirror image. So basically I'm doing 180 minus 34, and that's going to give me 146. So that's my other answer. Okay. Then over here, I'm doing the same thing. If I go 63 degrees this way, my sine, remember, is negative 0.8931 because the y coordinate is negative. Where's the other one? The other negative one is over here on this side. So I've got to think, you know, I'm going 63 degrees down this way because I got to have a mirror image. So what angle is right here? So really I'm doing 180 plus 63. So that's going to give me 243. So that's my other answer, 243. So now I've got 4 answers now, and let's check out and see what happens, how I'm getting this, all right? So 34 and 46. So as this thing goes around 34 and 46, so as this green line rotates around from 0, rotates this way, so when it gets to 34, there's this vertical line. And as it rotates around to 146, here's this other vertical line. So this vertical line is for the 34 degrees. This vertical line is for the 146 degrees. Okay. All right. 34. Okay. Now the other ones are 243 and 297. So then as we're swinging around this curve this way, all right, this one is going to be the 243 and this one's going to be the 297. Because the graph goes around this way, hits here first, and then hits here, and then comes back around. All right. So there's where our vertical tangent lines occur. They occur at 34, 146, 243, and 297. All right. And normally, you don't normally have to do the quadratic formula. That was just a difference. And a lot of times these are going to be trig values on the unit circle. You're not going to have to use a calculator and do inverse sine. But I wanted to show you one that was a little more creative, a little more, harder than what you're actually going to be doing on the AP exam. All right, the next one, number 5. And this has 2 questions to it. So this is 5A that says, for the cardioid, so here's our cardioid, find the slope of the tangent line at pi over 3. So this is just finding your slope. So we are pros at this already. So dy dx, our derivative is our slope, right, is dr d theta, both top and bottom. And then on the top, you're multiplied by sine, and then it's plus r cosine. And on the bottom, it's cosine minus r sine. So it's just a matter of memorizing that. All right, dy dx then for our graph we are looking at here, we want the derivative of r in terms of theta. So the derivative of 1 goes away, and the derivative of sine is cosine. So we're going to have a cosine in the top and the bottom. All right, so in the numerator, we're multiplied by sine, plus, and now we need our function r. So we put the whole function r in here, 1 plus sine. Then you're timesing by cosine. Then in the bottom, you're multiplying by cosine, subtracting, and then you're putting in the whole function r, 1 plus sine, and then multiplying by sine. And then you're simplifying if you want to. You don't have to simplify if you don't want to, because basically all we're doing is multiplying. We're putting in pi over 3, but we're going to need it in the next problem anyway, so we might as well simplify a little bit. All right, so what are we getting up here? We're getting cosine sine And then distributing this in is going to give us a cosine plus another cosine sign. In the denominator, we have cosine squared, and then distributing this in is going to give us a minus sign, and then a minus sine squared. All right, so dy dx is going to equal, I'm going to have 2 in the numerator, 2 cosine sines in the numerator, plus a cosine. And in the denominator, don't have anything special going on that I can combine. So I just have cosine squared minus sine squared. A lot of algebra, All right, so the problem said find the slope when theta is pi over 3. So now that I've got this simplified, all I'm doing is I'm evaluating dy dx, and most people put a vertical line right there and they say theta equals pi over 3. So we're evaluating this answer when theta is pi over 3. So I'm just substituting that in. So I'm going to do 2 cosine pi over 3 sine pi over 3 plus cosine pi over 3. And then that'll be cosine squared of pi over 3 minus sine pi over 3 minus sine squared of pi over 3. So now we just got to figure out on the unit circle at pi over 3 what the sine and cosine are. So on the unit circle, pi over 3 is 60 degrees. So we're up here 60 degrees. So that's going to be the ordered pair 1/2 radical 3 over 2. So that's over a little and up a lot. So 1/2 radical 3 over 2. So remember, cosine's the x, sine's the y. So now this means my answer is going to be 2. I need the cosine. So the cosine's 1/2. Then I need the sine. Sine is radical 3 over 2. Plus the cosine again. Cosine is 1/2. Then I need the cosine squared, so the cosine's 1/2, minus the sine, and the sine was radical 3 over 2, minus, and then I need the sine squared. The sine is radical 3 over 2. All right, so now we're just simplifying this, okay, and seeing what we get. So 2 times 1/2, that cancels. So I basically have here radical 3 over 2 plus 1/2. So that's radical 3 over 2 plus 1/2. And then here I have 1/2 squared is 1/4. And then this is minus radical 3 over 2. And then this is going to be minus, this is radical 3 over 2 squared is going to be 3/4. So then I'm getting radical 3 over 2 plus 1/2 is still in my numerator. I'm not going to put that together. So let's see here. We got 1/4 minus 3/4. So that's going to be minus 2/4. So that's negative 1/2 minus radical 3 over 2. Ooh, these are the same. The only difference is this is multiplied by negative. So the answer is negative 1. So that means the derivative, the slope of the tangent line, for this function, 1 plus sine at pi over 3, all of that work, yes, all of that work, and we've got the slope of negative 1. All right? So now, part B of this problem, it's the last one. Part B of this problem. We want to know, find the points on the cardioid where the tangent line is horizontal and vertical. Okay? So if you look at this nice little graph we got going on here, we're going to have 3 horizontals, okay, if you look at that picture. And then you're going to have 1, 2, you're going to have 3 verticals, because you're going to have a vertical here where this comes in here to this little peak, okay? So we're going to have 3 horizontals and 3 verticals. So we're looking for 3 answers for each. And I've got here that little memory thing for us to remind us. Watch out for where dy d theta and dx d theta are both 0. That can't be. You have to use L'Hopital's rule to figure out something extra to do. All right, So this is the same function as we had on the previous problem. So our derivative, dy dx, let me just write it down for us from the previous problem. It was 2 sine theta cosine theta plus cosine. And then the bottom was cosine squared minus sine squared. So that's what we just had in the previous problem just a few seconds ago. All right, so to do horizontal and vertical, we got to look at where we're both, where the top and the bottom are 0. So to do horizontal, we want the top to be 0. So for horizontal, we want 2 sine theta cosine theta plus cosine. We want that to be 0. Okay, so let's start there. So to be horizontal, we want the numerator to be 0, but not the denominator. All right, so let's just figure out what's going to happen here. So to solve this, the numerator said equal to 0. I notice I've got a cosine in both parts, so I'm going to pull out a cosine. So I don't need to, since I can factor it out, I don't need to replace it like I had been doing on the other problems. So if I take out a cosine, that leaves me 2 sine plus 1 equals 0. Then I can set each one of these equal to 0. So basically I'm factoring, and then I'm setting each piece equal to 0. So this gives me sine is going to be negative 1 over 2. And so now I just got to figure out the answers. So where on the unit circle is cosine 0? Well, cosine is 0, which is your x-coordinate, at pi over 2 and 3 pi over 2. All right, now over here, we're looking at where sine of theta is negative 1/2. So where do we have a negative 1/2 on your unit circle? So you just think on the unit circle, where's your sine coordinate? Negative 1/2. So over a lot, down a little, over a lot, down a little, where your negative, the sine is negative 1/2 on both sides. So that's going to be here at 7 pi over 6, because that's 210, 7 pi over 6. And then over here at your 330, which is your 11 pi over 6. Okay? All right, now notice I got 4 answers. And remember, we set up in our picture that we only have 3 of them. Only 3 are going to give us a horizontal tangent line, okay? So we're going to come back to that in a minute. All right, so let's change my color. Well, I'm doing this backwards from what I got up there. Oh, that's going to bother me. Let me fix it. So my horizontal tangent lines, see, that's going to bother me. My vertical tangent lines, I'll do blue. And my horizontal tangent lines, we got 3 of those, okay? Because I'll match it with my color, with my colors that I'm doing my pins in. So my horizontals are red, and I just did horizontals. I got 4 answers for the red ones. And then for vertical, I'm doing blue, so I got, and then here where it comes into the peak, that's a vertical, because this is a cardioid. So it looks like a upside down heart that's not at a point. It has a rounded end on it. All right, so now to do vertical. So to have a vertical tangent line, you want your denominator to be 0, but not your numerator. So let's look at our denominator. Cosine squared theta minus sine squared theta. We want that to be 0. Okay. So how do we work that one out? Now this one you can't factor or do like we did up here where we factored the cosine out. We can't factor it or do anything like that to solve for sine or cosine. So we need to replace it. And since we have 2 sines, it would be easier to replace the cosine. So again, you're using that popular identity that you already know, that cosine squared plus sine squared equals 1. So cosine squared is going to equal 1 minus sine squared. Okay? So we're going to replace our cosine here, our cosine squared, with 1 minus sine squared. So 1 minus sine squared, and then minus sine squared equals 0. All right, so that's going to give me negative 2 sine squareds, because I'll put my higher power first. So I got negative 2 sine squareds minus a sine, and then a plus 1. Now, because my higher power here is a negative, I'm going to multiply through by a negative 1. So that'll give me 2 sine squareds plus sine minus 1 equals 0. Now, this is just like the other problem we did, except I don't have to use quadratic formula. this actually factors, which is typically what's going to happen instead of having to use quadratic formula like I did on that previous problem. I can actually factor this. So 2 sine squared factors into 2 sine times a sine. It's like having 2x squared, 2x and x. And then the factors of 1 are 1 and 1. And I want to have a positive sign in the middle. So I need to have a positive 2 sine minus the sign here to get the positive sign in the middle. So there's the problem factor. So now we set each one equal to 0 individually. All right, so on this one, sine's going to equal, move the 1 over, divide by 2, so that'll be 1/2. For this one, sine's going to equal, move the 1 over, -1. So now I'm just solving these two problems. So when on the unit circle is sine 1/2? So what answers is that going to happen on? That's going to happen, okay, think about on the unit circle where sine is 1/2. So that means you're over and up 1/2, and then over this way and up 1/2. So that's going to be at pi over 6 and 5 pi over 6. So that's going to be at 30 degrees and 150. So 5 pi over 6 is 150. All right. Now we look at where is sine equal -1. So where is sine -1? Well, that's down here at 3 pi over 2, right? 0, -1. So the sine is the y-coordinate. -1 is going to be here at 3 pi over 2. Okay. So now I got 3 answers for this one, okay? But one of those answers repeats with this one, okay? Now, we already know what the picture looks like. So obviously we're like, okay, these are the 3 answers for the vertical, which means up here, this is not vertical for this one. These 3 are the horizontal. Well, that is true, okay? That is very true. All right, but what we need to do is, since we have this number, 3 pi over 2 for both answers, right? 3 pi over 2. That means up here in your derivative, 3 pi over 2 makes this 0 over 0. So that makes our derivative undefined. So let's do L'Hopital's rule to figure out what the answer really is, okay? So what does that mean? Since I have both of them, let me change my color too so I can differentiate this. All right, both of them equals 0 when theta is 3 pi over 2. Okay, so both of them equal 0 when theta is 3 pi over 2. So what we have to do is we have to do the limit as theta goes to 3 pi over 2 for your derivative. So our derivative was 2 sine cosine plus cosine divided by cosine squared minus sine squared. So what we're going to do, we know that when we put in theta approaches 3 pi over 2 into our derivative, this is going to give us 0 over 0 because we just found that answer in both pieces. So that means I'm going to do L'Hopital's rule. So L'Hopital's rule, because I got the indeterminate form, right? All right, because I got 0 over 0, so I got the indeterminate form. So I can do L'Hopital's rule, which means I can take the derivative of the top and the derivative of the bottom and then plug in 3 pi over 2 again. All right, so let's do that. So let's do the derivative of the top. Now this is product rule here. So this is going to be first function, 2 sine, times the derivative of the second function, which is going to be negative sine. So that's first times derivative of the second, plus the second function, cosine, times the derivative of the first one. So the derivative of this is going to be 2 cosine. So I'm going to have that multiplied by 2 cosine. All right, so that's first, derivative of the second, plus second times derivative of the first. Then plus derivative of cosine is really a minus sine. Okay? Now, down here on the bottom, the derivative of cosine squared. Think of that, remember, as the 2 on the outside, so I need to multiply the 2 to the front, keep the cosine and drop a degree, and then chain on negative, the derivative negative sine. All right, then the derivative minus derivative of sine is cosine. Then this is going to be minus the derivative of sine squared. Remember, this is sine raised to the second power. So I move the 2 to the front. sine, drop a degree to the first, then chain on the derivative, which is cosine. Okay? All right, so where do we end up? Let's simplify this a little bit. So let's see here. I got -2 sine squared plus 2 cosine squareds minus sine. And then here we got -4 cosine sine minus cosine. All right, so that looks beautiful. All right, so now we want to put in 3 pi over 2 to see what our answer is. Now, the nice thing about 3 pi over 2, at 3 pi over 2, cosine is 0. So that means this is going to be 0, this is going to be 0, and this is going to be 0. So I know I'm getting 0 in the denominator. At 3 pi over 2, the sine is -1. So this is giving me -1 squared, which is going to be 1 times -2. And then -1 subtracted will be a +1. So I'm actually getting the answer -1 over 0, but because I've got a number divided by 0, this is undefined, which means it approaches infinity. So that means for this answer, 3 pi over 2, the slope of the tangent line is undefined, it's approaching infinity, so that means this is a vertical tangent line. Indeed, okay? So up here in my answers then, I'm able to conclude that for my horizontal tangent lines, it's pi over 2, 7 pi over 6, and 11 pi over 6. And for my vertical tangent lines, I'm able to conclude it's pi over 6, 5 pi over 6, and 3 pi over 2. All right? So so this one is not horizontal, it's a vertical. So verticals are at pi over 2, 7 pi over 6, and 11 pi over 6. And then the horizontals are pi over 6, 5 pi over 6, and 3 pi over 2. And you're able to see as you rotate around this curve, if I can remember here the numbers as I tell you here. All right, so as we're rotating here from 0 to pi over 2, so the first one, pi over 6 here, that one is a vertical tangent line at pi over 6. Then as I rotate around here to pi over 2, that's your horizontal at pi over 2. All right, then we keep on going over here. Over here, I have 5 pi over 6. That is a vertical. Then here is my 7 pi over 6 is my horizontal. Then my 3 pi over 2 is my vertical again. Then here is my 11 pi over 6. That's my horizontal again, and I'm back to the beginning. All right, I'm to 2 pi. So as I rotate around, I can see all those 3 values as I'm rotating around that picture. I can see these 3 values going around the drawing, okay? And because we got 0 over 0 for 3 pi over 2, that's where you just have to do that extra step of the limit and do the L'Hopital's rule to see what the answer really is for the value of the derivative at that value where you're getting 0 over 0. You've just got to do that extra investigation to see what happens. All right, so that was the rest of 5B. Now, number 6 is one where you can just play around putting it in the graphing calculator. Make sure you're in polar mode. Put your window in here. I've got your window set for you already, okay, of what it should be. Here's your function. Put your calculator in polar mode. Put in this equation, put in these numbers, and then select graph. And it's going to graph a beautiful, nice little polar curve that's just cute to see. So these are a lot of neat things that you can graph on the graphing calculator. All right. And pause your video because I'm going to go ahead, if you're still typing it in, I'm going to go ahead and show what it looks like. So if you're still typing your calculator, just pause me until you get it in, and then you can keep on going. So here's what you should get on your calculator if you type it all in correctly. So a nice little spiral graph thing. It's kind of cool. Cool, cool, cool. All right, so this is your assignment for doing for this part of our polar curves and doing tangent lines and finding the derivative. So you're on page 62, you're just doing 54, and then numbers 55 to 63 odd, so that's not very many. So you can practice taking derivatives and finding horizontal and vertical tangent lines. So good luck.